Hello everybody and welcome finally back to a new tutorial. First of all, you can already see it. I'm currently got a sale on Gumroad, so you get 50% off for the next few days on all my courses, etc. The link will be down in the description. And another thing, currently on Patreon, there are a few new releases. My organic shape tutorial, my flacon tutorial with growth, etc. And I'm currently working on the next tutorial for this month. It will be about volume advection with particles, rendering, look depth, etc. So, what I want to do with you today is like to get a refresh, a new start in Houdini, Houdini getting started basically, and we will build a little geometry with subs, and we will deal with rendering, etc. So we will get started. When you start Houdini up the first time, it will look something like that. So you got your node network basically down here, and you got your parameters down here. And what I usually do, I will just click them away. So I got a big view on my nodes. And for example, when I place down a geometry, of course, I want to manipulate that. Just press P on your keyboard and you will get the parameters here. And then you can save it here, save current desktop. And when you go to preferences, you can go to general user interface and startup in desktop. You can then, for example, choose a startup screen you like or layout, and you're good to go. Okay, we will first place down a geometry node. We will press tab, or you can also press right click and type in geo. In this container, we will build up our geometry. So let's call it GeoRD for research and development. And we will dive inside with double click, or you can dive inside with I, and you can dive up with U. So up and down into the infinite rabbit hole of Houdini. So we'll do like, I think a find shortest path is a nice way to begin with. Let's start with that. So what I want to do is to maybe get a sphere. So press tab, type sphere. And what I want to do, I want to get that from a polygon mesh to a normal polygon. And we can then dial up here the frequency a little bit. For example, I think 10 is fine for now. And now what I want to do, I want to copy the sphere on the sphere again with a different scale. So I want to create like a base geometry so we can then start our find shortest path. What we can do, we can place down a scatter node, for example. And when we placed that node down, we then can view that with the little display render icon here, or just press R on your keyboard. Now we got points, and with those points, or on those points, we can scatter more geometry. So for example, copy to points. When we now get here, the right input will be the points, and the left input, when you hover over with your mouse, you can see required geometry to copy, and required the points to copy to. So those are the points we want to copy to. Let's go for, I don't know, 25 for example. copy our sphere, you can do that with, of course, Control C, Control V, or just Alt and drag it out, and you then can copy it. As many as you like. When you connect that and view the flag here, you will see we created this funny looking geometry. So now, of course, Houdini is procedural. When we, for example, stretch the sphere out above on the y-axis, you can see you'll get a different kind of shape. So maybe we'll leave it like that. And now I want different scale. You can do that with Vex, of course, you can do it with VOPs, or you can just use, for example, attribute create node, or you can use an attribute randomize. Attribute randomize, you can use that, you can use attribute adjust float, or you can use noise float adjust. So to just give you like set initial. So you can do it with that, with that, with that. You can do it with an attribute wrangle and with an WAP. So there are like really a lot of ways to set your P scale. So your individual scale for each sphere that will be copied onto our points. We'll use now, for example, just the attribute randomize. You can see it's currently set to CD. You can see it here. When we pipe that between here, you can see that the color will change. That's also a cool thing. So you can use your that color later, for example, in rendering. But what I want to do, I want to manipulate not the color, I want to manipulate the P scale. So just type in P scale and go to custom ramp. And now you can see we will manipulate here our P scale. So with this ramp, we can now manipulate the scale from our copied spheres with this little ramp here. And under options, you also got like a global seed. And what I want to do now, just place down an attribute wrangle. And let's call that mold P scale. And in here, I will just type float at P scale times equals, and then channel F for channel float, brackets, and let's just call that mold semicolon, and we are good to go. Let's hit apply, and this little create spare parameters. And now we've got like an overall multiplier for our spheres here. So it's just basically use the P scale attribute and times equals. So again, multiply P scale with our given channel float. So that's just a little Vex snippet that you can use, for example, to multiply a given attribute. So now we got our sphere here. Now what I want to do is like mesh them together. We can use VDBs for that. So first of all, let's just place down here a null and call that out spheres. And with those spheres, we can then further proceed. But for example, a null node, I use that in private or commercial work all the time to just get a viewing point on my node network. Because when it's like that big, and you can just zoom in here a little bit and you can see, oh, there's a null node, there will be maybe an output or an input, etc. So now we've got here our output, our spheres. We want to mesh them. But first of all, let me get a sip of tea here. Okay, perfect. Now we want to mesh them. So we'll place down a VDB from polygons. And now you can already see we will create now voxels out of our polygons, basically a volume. And now we can remesh them or reconvert them into polygons. So convert VDB. And we want to convert not to volume, we want to convert to polygons. And now you can see we meshed our spheres together. Now the nice thing is we can play with the given resolution here. So for example 0.01, it's a pretty high resolution. Or we can just go a little bit lower, for example 0.05. And in between this meshing process, this conversion process from polygons to volumes and then back to polygons, we can manipulate our volume. So when we type VDB here, you can see we've got a lot of nodes to work with. But for example, one really nice, interesting node is, for example, VDB smooth SDF and the reshape SDF. With the reshape, you can see we can, for example, dilate our volume, or we can erode our volume, what is also really nice. So first of all, let's dilate it maybe a little bit, just like that. Then we can smooth it, for example. You can get like a really higher smoothing factor with the iterations. And you now can see we've get already a really nice organic looking shape. And now, for example, we can drop in here another reshape and use erode on that if you want to. Just erode it a little bit. And you can, of course, always adjust the resolution here and get a higher detailed representation of your original, or you can go with lower resolution and then, for example, remesh it downstairs again for higher resolution. There are several tools. For example, what I really like is the exercise quad remesher. You can just buy it and get really nice topology out of there, and then, for example, just subdivide it a few times and you got a really good looking high resolution mesh with quad topology if you need it. Another thing, there is the labs instant meshes. That's for free. That's in the instance tool, in the lab tools. You can just type in here poly count, and it will also do a pretty good job. Or you can use, for example, remesh to get like a low poly style. Or you can use your remesh for higher resolution. So for example, target size 0.01, and then it will remesh the whole geometry to a given edge length. So you can use that. Or what you also could do the whole process again if you want, without those, and then here higher resolution. You can also do that, for example. So there are really several ways to deal with that. But what I want to do, or what we want to do, is to generate a find shortest path along this geometry. And we will start with a simple node called group. This will be our group node. You can already see it's a little bit customized, $OS. You can type it in here. And what that will do, grp start PTS. This is for group starting points. Let's select your points, and let's select your points down here. You can see the group is already named group starting points because of the $operator string, and this is that one. Okay, so now we got points. and we got a point group. What we can do with those? That's pretty cool. But first we need another node. Let's go for the labs, and you can see here a really bunch of nice lab nodes. You can install your labs toolset with the shelf tool, with SideFX Labs, and here update toolset. And basically it's with the launcher, I think, in the newer versions. So definitely install the lab toolset, really nice. And there is the labs random selection. So we don't need to build that ourselves. It's already there and it's really nice. Random selection. First of all, let's start with exact number, randomize element order. And let's start with the ratio. And you can already see here is the mark checked, color selected. And now we can visualize what points are currently selected. And with the random seed, we can of course change the seed of our selection. And a nice thing is we can create a group from selected. And we will name this group, for example, group end PTS for endpoints. And now when we go to our geometry spreadsheet, let's just hide all and go to group attributes. You can see we've got two different groups. One, the group endpoints and the start points. And now you can disable the visualization, for example. And what we can do, we can place that on the find shortest path. I also got a tutorial on that, I think 1 or 2 years ago. And now when we got our find shortest path down, we've got here the start points and the end points. For the start points, we will use this group, so the start points, and for the end points, we will use the end points. And you can see nothing will happen. We'll first of all need to change that from any start to each end, for example, or from each start to each end. And now you can see we've got basically a wire growth or a curve growth effect over our mesh here. Wait, here. So the find shortest path will calculate the shortest path between each group point, and we will end up with something like that here, which is pretty cool looking. Now what we can do, those are currently just polylines. We can, for example, remesh that and so on. And what I want to do, I want to resample them. So resample. And I want to get like a pretty good resolution on those. For example, 0.01. And now you can see those are resampled. They got a higher point count. And I do blur. I want to do that also. I want to blur the position a little bit. So disable the pin border points and go to proximity blurring. And now you can see we can blur those down a little. That's looking good. And the cool thing is, of course, we can change the seed up here. And we'll get a whole different geometry growth. For example, we can also make it higher and we'll get it like much denser. Or we can go down with the ratio, like really down, and only make like a few connections. Let's just leave it maybe to 0.01. I think that was a good amount. Cool. Now you can blur it with attribute blur, or you can use the smooth node. See it here, for example. And you can go down with the filter quality and go, I don't know, 250, for example. to really like blur it out. And now what we can do, we can use the VDBs again to process those lines. What I want to do first, I want to grab like one single line here. Let's go to primitive and blast away one primitive. Let's choose that one here. Press enter and then delete non-selected, and we've got one single line. And with the single line, we can now place down a VDB from particles, and particles are basically just points. And when we place that down, you can see we will get something like that. Let's just shrink down our point radius scale to 0.05 and our voxel size to 0.025. And now when we disable our blast here, you can already see we created here another VDB from our lines. Let's get a little higher resolution in here. So just drop that down again. That's looking pretty cool. Let's go a little bit lower. 0.5 and 0.5. And it's maybe a little bit too thin. And the cool thing is what you then again can do, grab those here and play with those remeshing tools. So for example, dilate it a little bit again to get, for example, connections or loose connection or connectivity between the VDBs. Then you can smooth it. So to get like a really organic looking thing, let's just go for 5. And let's dilate it a little bit more. Maybe that's too much, maybe 2.5. Maybe 2. And erode it a little bit again. And after that, we can again convert it back to the VDB polygons. And now you can see we've got that really organic mesh. But you can also see, for example, we've got here one little disconnected blob. So what we can do, we can place down a VDB segment by connectivity. Pipe that in here. And now you can see this little disconnected blob will be highlighted in another color. And we can blast that away. So we will blast away surface 0, delete non-selected. We got only our mesh without any connectivity issues on the VDB side. What we then can do to get the red off, attribute delete, CD. Oh no, that was not CD. So yeah, primitive, just delete the color on the primitive. And now we can render that, for example. So the nice thing is, we can now copy our whole tree here. And we can iterate on that tree. First, wait, just get started. That should be fine, yes. So let's just go, I think find choice path is the best to compile speed-wise. And now, for example, just get one here, we will get something like that. I don't know, get 2, make that thing wider. Just be sure to that those are connected here in our, for example, you can see those down here are not connected. Maybe you can pipe up our, let's just introduce here again. So we just get the biggest. Now the start points, of course you can make the start points random too if you want. Just have a look on that piece here. Yep, also looking cool. And the nice thing is with the smooth and with the erode, you will get like a really nice looking mesh. It's not a question what mesh is nicer. I really like both. Let's just experiment here a little bit longer. Maybe change the global seed here a little bit. Oh, that's looking nice. Like a sculpture a little bit. Let's just use that. And what I want to do, I want to start here and down here. Let's resample those, smooth those a little bit out. And what we can do, let's just go down here a little bit with the ratio. Or maybe go up again, because that looks nice with that thing here. And what I want to do, I want to dilate it a little bit more. Maybe 2.5 is a okay-ish value. No, let's go for 4. I think 4 should be. Let's go for 3. Let's use 3.5 here. I think that's better. That's looking cool. Now what we can do for rendering, for example, let's go match size. Let's pipe that up, min. And maybe scale to fit. So we got like a good scale here. Let's call that out. Whoops, not put. Out mesh or out. Let's call it out final. Out final. And this is our mesh. Can render. What you can do, you can apply, for example, another smooth. If you want like a really organic looking thing, you can just dial down the filter quality to 1 here. And then go here, for example, like 250. Will take a little bit. Yeah, and you can like really smooth it out. You can even go, I don't know, like 500. Yeah. Also looking pretty cool. So that's fully up to you if you want to do that. You can also go for a little lower value, for example, I don't know, for 25. So that's not so high. Or let's go for 50. Let's go for 5. Yeah, something like that. So now we've got our tree and we've got our final geometry here. Now, of course, you can play with, for example, what you could do. You could use this shape here, your original shape, to blend that or to merge them together. So let's just merge them. Let's get a merge node. Merge them together, for example, and you can like maybe bool it, etc. You can remesh it. You can union those together with VDBs. Or what you also can do, you could get your really your original mesh blended and Oh, maybe let's just do that because I think that's looking pretty funny. VDB from polygons, or we can just use that one here, that output. Let's just place a null here and place a null here quickly so we don't lose those. So we got our spheres and our VDB. And let's just quickly convert those from VDB from polygons also into polygons. Let's go for pretty okay-ish resolution and a VDB combine. With the VDB combine, it's like a boolean for VDBs. We can go for SDF union and we can union those together, and we will use the smooth and convert to just connect those, and you will get something like that, kind of alien looking, I don't know, with really nice connections here. I think those are looking pretty cool. And of course what you can do, you can erode those, of course. So reshape in here, not, it's currently on dilate, but you can erode those. For example, like 5, to get more of your created structure with the find shortest path. So you can get something like that. And I think that's looking pretty nice. That's looking... Yeah, why not just use that here? And what we also can do then, let's just convert that little piece here. That one here, right? We can use that as a mask from geometry as a reference. Type that in here. We can use that in Redshift for rendering. Let me just look it here. Okay, easy. Now press the little visualizer button here and scale down the radius. We can use that as an attribute for shading, for example. And you can play with the radius here. For example, let's go like that. And what I want to do is place down an attribute blur node, and I want to blur not position, I want to blur mask or newly created attribute a little bit. Now you can see when we pipe up here the blurring iterations. Let's go for 25 and step size. Go for 185. You can see we can blur out our attribute a little bit. That should be nice. And now what we can do, let's just get that again. Connect this. And this will be our final output. And let's just don't use the smooth that high. We just go for 25. I think that's looking pretty cool. Oh, funny. So now we've got here our output. Let's place down a material. So we'll set here R as matte. Let's go organic shape. And maybe let's get a little podest or something. Let's get a box here. And we will do the inverted thing. Set that on max. Let's just merge them both. Now we can create here a little stand for our, let's look at top, for our newly created geometry. Maybe like something like that. That should be fine. And also let's make a material here. rs mat, let's call that stand. Put that together. And those really sharp corners are not that realistic, so let's use a poly bevel and just bevel those a little bit. I think that should be fine. Cool. Now we've got two different objects merged. We've got two different material assignments. Let's just get that down here. Cool. Now let's dive up and we will create a camera. Let's call that camera, maybe close up R&D. That will be a look depth 001. And now for the focal length, let's go for more like portrait lens, 85 millimeters. Dive inside a camera, so you can do that by no cam, just click here the camera, and now you are in your camera. And with your show handle tool, and be sure to lock your camera or view, you can then zoom out. Maybe for the thumbnail I will like rotate that 90 degrees. It will fill it out better. But for now, this is like our camera here. And wait, that's like the back side. Get our camera to the other side. Like that. I think that should yeah. You can split your views with Control 1, 2, 3, 4, for example. And I think that should be fine for now. So let's just dive out of here. So we got our camera. Then we need, of course, materials. So place down a material network, not a simple mail. We will need a material network. Of course, you can also do it in here, but I like to keep those all in a good range, or like in a local space. So that will be our RS material library, where we will create materials soon, and then a RUB network, so a render network. Let's call that RS out, and place down a Redshift node. Let's call that RS out 001. Oops. And it's basically pre-configured. But yeah, just leave it the same for now. Radiance, okay. And there's our custom mouse here. Oh, okay, nice. Then let's just grab our camera here. Accept. Okay, then dive outside. And now, of course, nothing will happen because we need a light. For example, you can use HDR. Let's just use that for now. RS, let's call it dome 001. And I will choose a dome light here. Metal Studios. Use that. And we'll just dive inside the camera. Oh, one more thing. I will use like a bokeh image. And just set the focus distance. Circle of confusion down. And And now when we press, I got it on a hotkey, Control Alt Shift R for rendering. But you can just go here to your shelf tools and render view. And now let's set the focus. And you can also already see it. Ta-da! We've got an image. But we will need to apply a few materials. So we'll need basically two materials. So place down a R as material builder. And let's just call that R as matte organic shape. And the other one will be our stand. And we need to apply those. So just dive back in our normal sub window, press Shift W, and you will get this little tree viewer here, and select our organic shape. And now the cool thing is you can drag and drop this in here, and our stand, drag and drop this in here, and you already got a relative path. And with Shift W, you can then collapse back in the tree viewer. So I find it pretty handy and pretty fast to deal with. And now we've got our materials assigned, so the frame will get a little bit darker because those are set on 0.5 gray. And now we can play with materials. So let's just use white for that now. And what I want to do, I want to import our mask attribute. So color, we'll use the R's color user data, and we'll type in here not CD, we'll use mask. And just pipe that currently to the surface output and refresh the window here. You can do it with here, or I got it on hotkey. You can go to preference, shortcuts, and for example, I got refresh IPR on Q. And you can see now we've got our mask. So the cool thing is what we can do, we can blend with that mask between bump maps, we can blend between different materials, we can use that for color. So the easiest example would be place down a ramp, and let's just go from white to an orange color here, be a little bit desaturated, connect that and connect that to the base color. And now you can see we are blending between those colors, which is pretty nice. But another cool thing is we can not only blend between colors, we can blend between several materials. So we can use, for example, two materialities in one shader network. Let's place again a standard material and a material blender. So R is material blender, connect that. We will use a base material. This will be our white, for example. And we use another material. Let's just use a bluish tinted metallic material. So just pipe up the metalness here. We'll use that as a blend color, our mask, and we'll introduce here our seg material. And now you can see we've got our organic shape with two different materials here. So the one is metal and the other is like a diffuse material. Now we can play with the roughness here, of course. We can use, for example, what I think would look pretty cool is glass. That's cool. We can use tinted glass, of course. Let's just use tinted glass here. Or maybe in a kind of bluish tone. Let's desaturate that a little. Play with the index of refraction. Let's go 2.8. We can play with roughness, so we can make it a little bit rough, for example. And what we then can do, for example, for the other material, we'll use a noise. Let's introduce a little bit of detail in here. what we can do, we can place down a max on noise and pipe that quickly to our surface output. Let's change that to Luca. And that's already a noise that got really a lot of detailing. And the nice thing is we can then use another noise. Let's go for displaced turbulence. And I want to scale that a little bit down. So for example, 0.328. I think that's nice. And we can composite those noises together. For example, average, and we average those two noises out, and we can use that as a bump input. Let's just place down a bump map, pipe that into bump input, pipe that out again to surface. And now, of course, that's way too high. So let's go down with the scale here. 0.01, yeah, let's go 0.05 for example. Now you can enable a bucket rendering here, and you can see we've got already really nice detail here. Other cool thing is we can now use that color information to recolor our material. So let's just use that as an, and you can go from an orange to, I don't know, a red maybe. And you will get something like that. That will look not so nice. Let's go for more desaturated color palette. That's looking much better, like complementary. But let's go. I really liked the white. Go for grayish, or let's go for white here, and that's grayish, that's fine. And now our stand, I think it looks already okayish, but of course you can go for like a metal stand and pipe up the roughness a little bit. And now for other aspect ratio, you can go, for example, like 6:45. 2.3. What wrong? And let's just go in here. And that will be the other camera. And we need to rearrange the focus, of course. And maybe the depth of field a bit too high, so just drop down the COC radius. And now we've got something like that. Looking not too shabby for, I don't know, let's have a look. 48 minutes. And now the cool thing is you can change the seat. Let's just do that. Let's just do that and have a look what that will give us. I will block that here. It will be a surprise. So just get this scatter seed here, copy it so we can preserve our original creation. And of course it will then pipe that down here quickly, but we will need to change the seed because it's currently the same. Let's go for I don't know, 1, 2, 3, 4. And let's have a look. So it will, now you can see down here, it will run down. It will go for the mask from geometry, so it's already basically finished. And now let's start the render and see what we will have. Yeah, we all got something like that. Let's go for seed 5. And now the cool thing is you can basically experiment, of course. You can also deblock your view here to get a little bit of a better art. direction. Yeah, and now you can play basically with that. So again, choose your geometry here. Was it not the same? No, no, no. Okay, let's just use that. Let's run it down quickly. Let's run it down. And we will get something like that, which looking also pretty cool. Okay, guys. Or okay, everybody. Now we're finished with that. Of course, now you can really explore and dive inside with, for example, different bump maps. You can play with the intensity. You can play with the color. You can play with different materials. For example, what you could also use here, or maybe on the glass material or on the diffuse material, just use, for example, subsurface material. Let's just use that. Wait, one scale. Just use that, for example, and it looks already pretty cool. So you can use that, for example, too, and go wild with the color, etc., etc. So I hope you liked that refresh of getting started, and I will see you in the next course, in the next Patreon tutorial, or on the next YouTube tutorial. So I wish you a great rest weekend today, and I will see you in the next video. So take care and bye.